Some help, okay? Please don't do this.
All right, well, we'll go ahead and get started. Thanks everybody for joining us today for the NCLUG Tech Talk on NCDOT hydraulics standard workflow for drainage ditch design using ORD. But before we get started, just go over our housekeeping rules. This is a webinar presentation, so all attendees will be muted. At any time during the webinar, you can submit your questions into the chat box, and if time allows, the presenter will address any questions they can during the Q&A at the end. We will be recording the webinar and sharing the link on our website after the event, and we are offering PDH credits to those who have registered for the event online. And we will be sending those out, and hopefully we're catching up on the PDH credits for our past events too. So we'll hopefully have them out to everybody by the end of next week, since this is our last live event of the year for PDH credits. So with that, I'd now like to introduce our speaker today for a presentation is Mr. Carl Dauber, who's a professional engineer with over 36 years of experience providing hydraulic design services for civil engineering projects, particularly transportation infrastructure, including numerous projects for NCDOT. He's very familiar with Bentley, OpenRoads Designer, and drainage and utility software, and for his firm, Advancing Consultants, provides migration assistance to DOTs and private consultants, including configurations, developments of workflows, and documentation and training. In the past years, he's been working with a number of state DOTs, including North Carolina, Nevada, and Oregon. In the early 2000s, Carl assisted Bentley with software development through storm and sanitary steering committees and is currently advising Bentley development staff on needed software improvements as part of Bentley's Innovation Council. So with that, I'm going to hand it over to Carl. Carl, we appreciate you joining us today. Looking forward to your presentation.
All right, thank you. Well, hello, everyone. Thanks for joining us today. I do have a lot to cover, so I'll be going pretty fast, but as Patty noted, this is being recorded, so you'll be able to come back later if you wish and review the presentation at a slower pace. All right, today's topic is a new guidance document provided by NCDOT Hydraulics, which has been posted to their website. The document provides standard workflows for using ORD for ditch design. And note that the document was recently revised for version 10.10, so it is up to date with the DOT's latest workspace. The document's available on the hydraulics webpage. Browse to the resources for ORD drainage, and then select the ORD ditch design manual. So what's in the document? It covers design of ditches excuse me, that are outside the limits of the roadway corridor models. So this would include head and tail ditches, lateral ditches, and berm ditches, but it does not include the special cut ditches because they are part of the roadway corridor model itself. And so that's the roadway staff province. If you're interested in how ORD can be used to develop design data for special cut ditches, I have posted a couple of videos on my YouTube channel, which you can access through my website shown on the screen. There's a video showing an example of how hydro staff can design a special cut ditch using ORD, and a second video showing how roadway staff can then use that data to revise their roadway corridor model. The second video also shows how to project drainage ditches onto the roadway profile. I also want to briefly mention DOT's current thinking about coordination between hydro and roadway staff. Hydro staff will create ditch corridor models in separate DGN files. So this is a continuation of existing practice, and it's consistent with industry best practices to segregate data. This allows hydro staff to use the data in the roadway corridor models for their ditch design without having to be in those roadway files. It also allows hydro staff to work on portions of roadways that are completed rather than having to wait for the entire roadway design to be completed before they get started on ditch design. Roadway staff, for their part, they can either reference the ditch corridor models that Hydro has developed for their roadway cross sections, or they can incorporate the design data into the roadway corridors themselves. So it's really their choice. They can go either direction. So to briefly summarize the overall workflow, first, develop the initial layout of ditches using the ORD tools. And then you can do the hydraulic analysis once you have the profile set up of the ditches using whatever procedures and methods that you like to use, whether it's Flowmaster, FHWA Toolbox, ORD, drainage and utilities, and of course, the spreadsheets that we all love. So whatever procedures you want to use for doing your hydraulic analysis, you can continue to do that. And then come back and adjust the ORD ditch design based on that hydraulic analysis, adjustments to profile, cross-section dimensions, and lining types. And then once the ditches themselves are done, you can use ORD tools to obtain all the information you need for construction preparation and construction layout, baseline station, offset, and elevation for those critical locations that the contractor will need for construction. You can also use the ORD data to project ditch profiles onto the roadway profiles. And then lastly, you can use ORD to obtain ditch quantities as well. Now today, I only have time to cover a few items. I'm going to cover items 1 and 3 using ORD to develop the initial ditch layouts and using ORD to adjust those ditch designs to meet the hydraulic requirements. I want to briefly review the workflows for head and tail ditches, as well as lateral ditches, and just note how they're a bit different. For the head and tail ditches, they're pretty straightforward. It's following the same process that you're familiar with if you've done any corridor modeling. You create your horizontal alignment, add a profile, and then apply a selected template to create the corridor model. And then you make adjustments as needed to the profile or the cross-section dimensions and the lining types to finalize the design. Lateral ditches, it's a little bit different. We go straight to the corridor because we don't need to create a horizontal and vertical alignment for lateral ditches because we can use the roadway corridor for that. We can select a roadway corridor slope stake line and use that for both horizontal and vertical control for the ditch corridor, and then apply the template. And another thing that makes lateral ditches different is that we need to use point controls for the ditch corridor to set a ditch centerline profile that's independent of the slope stake line profile. And then lastly, just like with the head and tail ditches, we make adjustments to the ditch corridor as needed to finalize the design. Go into a demo now. I'm going to spend the rest of the time to get our time together demonstrating the tools in ORD for designing a lateral ditch using the DOT workspace. Because I have a limited amount of time, I won't be able to demonstrate the process for designing head and tail ditches, but that's actually a simpler process than the lateral ditches, and it's explained in detail in the new guidance document. So I'm going to go ahead, go into ORD. So I'm going to start with a new DGN file that I've created from a 2D seed, and then attach my reference files that I'm going to need. I have attached a existing terrain, attached the roadway corridor file, and the geometry for the proposed roadway. So the first step in the process is to make sure that I'm in the right workflow, of course, OpenRoads modeling. I need to set my existing terrain, set that as the active terrain model. Don't forget to miss that step, otherwise your corridor model won't process properly. And then since we're doing corridor modeling, we need a template library. We'll go up to corridors, template, file, open. I'm going to browse to the workspace location on the C drive or wherever you are accessing your DOT workspace. So I'm going to go there, go into configuration, org civil, disciplines, hydraulics. I'm going to go to the standards folder, the template library folder, and there's the template library that you need that's been created for ditch modeling. Open that up, close that for now. Now I have everything I need set up to start creating a corridor model. So I'll go to this tool here, new corridor. And with most things in OpenRoads, you need to check your feature definition, make sure you have the right feature definition applied. So the one that we're going to be using is HYD with contours. So we have a feature definition that's been set up for corridor modeling just for ditches. At the prompt, to locate corridor baseline, I'm going to select the slope stake line from the roadway corridor. And make sure you look at the attribute feedback that you're getting to make sure that you have the right element. This one's called SS fill, so that's the correct element that I want. So I'll select that. And the next prompt is to locate the profile. The slope stake line has its own profile. I don't need to create one for it, so I can reset to accept that. And it's going to ask me for a corridor name. By default, it will give you a name, the same name as the element that you selected. I'm going to give this a more meaningful name called lateral ditch 1, COR for corridor. Then I'm going to press the tab key, and when I do this, see this yellow graphic pops up. ORD has now created sort of a placeholder corridor model. It's an empty corridor model at this point because no template has been applied, and that's the next step. I move my mouse, heads up prompt will immediately ask for a template to be applied. I can go to the tool settings dialog and click on this ellipsis to bring that up, or if I like using my heads up prompts to do that, I can press the Alt down arrow key combination, and that'll bring up the pick template dialog as well. So this is a view into the template library is what this is. And note that in the lateral ditches folder, we have two subfolders. We have a folder called No Berm UCE, and this is for ditches where the ditch force slope is a continuation of the roadway fill slope with no berm. The with berm folder is for ditches where the ditch force slope is different than the roadway fill slope, or when a berm is being provided. So for example, we have this one here, and such ditches will typically have a berm between the slope stake line and the top of the ditch force slope. And this is what the template will create by default. But you can choose to change the berm width value to 0 if you want to eliminate the berm by using a parametric constraint, and I'll discuss that in a little bit. Notice also that these folders are divided into left and right sides, so you need to pick a template for the correct side of the road that you're on. I'm on the left side of the road in this example, and I'm going to select trapezoidal ditch with Class B riprap. I'll say OK. Then I need to just data point to confirm that selection. The next step in the process is to identify the start and end stop location for my ditch. Now at this point, note that the ditch needs to be stationed in the same direction as the roadway baseline. So it's not an upstream, downstream, it's a roadway baseline issue because we're using the slope stake line as our control, and that slope stake line has stationing associated with it, and that stationing is in the same direction as the roadway baseline. So keep that in mind. That may mean that your ditch is being stationed in a direction that's opposite of the flow. So I have some guidelines here that I've created. I'm going to go ahead and just snap to those. Start. Then the end. And then the last step in the process is to confirm the template drop interval. I could change that or just accept it and go ahead and accept 5 feet as my template drop interval. When I do that, the initial corridor is processed, shows up in the plan view, as well as the 3D model view. I want to just review the graphics that are being displayed here. I temporarily turn off display of the 3D model. So let's see what we have. We have a ditch center line in the light blue dash line. We have 2 lines here that represent the bottom of the ditch, the bottom width of the ditch. These red lines represent the limits of the riprap lining, which you can see in the 3D model view window. And the green lines represent the top of the cut slope. So this is the construction limits of your ditch. These other items here are corridor graphics that ORD produces to help you with editing. These are called corridor handles, these yellow dashes. And the light blue dashed line is the graphic for the templates. And I'll be using those quite a bit during this demo. If you want to turn those off, go to level display, and it's on a level called draft corridor graphics, so you can turn those off. But I'm going to keep them on because they're very useful for editing, as you'll see. I'm going to turn off the riprap ditch level just for clarity. And turn my level back on for the 3D model so I can see the contours. I want to note that these graphics levels, the contour handles and the element, template graphic, as well as the center line, are assigned an element class of construction. They're construction class elements, so they will not plot. Now notice that this initial ditch corridor has a low point in it right here. At this point, the ditch has a uniform depth such that the ditch bottom is a fixed distance below the toe of the fill slope. So it's following the profile of the slope stake line, and the slope stake line has a low point right here, and so the ditch does as well. What we need is to establish an independent profile for the ditch, and that will be the next step. Before I do that, I want to establish a cross-section view. To do that, I can go up into the ribbon menu here and go there, but I prefer to just go right here, select the corridor handle, and use the flyout menu. It's asking me to select a window to put the cross-section in. So I'll put it in there. And you can see that that shows all the elements of the ditch, including the riprap layer, as well as if you zoom in, there's a geotextile fabric in there. Shows you existing ground, as well as the roadway corridor model and all the data associated with that. Any 3D data that you have referenced up will show up here. So if you have a drainage and utilities model that's referenced, your drainage will show up here. Any proposed and existing utilities, anything that's 3D will be reflected here. So to establish the ditch profile, I need to add point controls to the corridor model. To do that, first step, I'm going to select the ditch center line and open up a profile model for it. And you can see that the existing ground here in white, and the initial ditch invert profile are displayed, and you can see how the ditch profile is mimicking and following the existing ground. To develop the point controls, it's helpful at this point to create a profile in this profile model window to lay out my proposed profile PVI points. So I'm going to create 2 reaches. I'll have a first reach here to about this point, and then a second reach from about the middle out to the end of the ditch. And for each of these reaches, I need to establish the start and stop stations, the start elevation, and the slope. So to create my profile, I'm first going to set my feature definition. You can see we have a folder for ditch design. Open up that folder and I'm going to select the TL ditch middle feature definition. And don't forget to turn this toggle on, use active feature definition. That way I won't have to specify feature definition for every piece of geometry that I create. And then I'm going to go back to geometry, vertical, and profile complex by PI. That's the tool I'll use to create my profile. I want to be sure to set my curve length to 0. I don't want to create vertical curves for my ditch profile. I want to give this a name. I always like to give geometry meaningful names. And I also want to turn on Civil AccuDraw. It's a very useful tool. And I want to put this in elevation mode. So Civil AccuDraw will help me to use precision inputs to create my profile. So I'm ready, I'm all set. I'm going to go ahead and snap to the beginning of this line. You can see station is highlighted. I'm just going to press enter to lock that station. And then I'm going to enter in my first elevation, 875.27. Press enter again to lock that in, and then data point to accept. Enter in my next station, press enter to lock that. Enter in my elevation, 869.7. Lock that, data point to accept it. So now that's my first reach. For my second reach, I want to, instead of specifying a station elevation, I'm going to use a specified slope. So I'll change the mode from Civil AccuDraw to slope mode. Snap to the end, lock the station, and then enter in my desired slope, minus 1.15%. Lock that, data point to accept it, then reset to exit the process. I can go and turn off Civil AccuDraw now. That's my profile that I want the ditch to have. Here's the profile that it actually has right now, according to the corridor model. And I want to make that profile down to this profile using my point controls. I want to show you just some editing that you can do on this geometry. It's typical for OpenRoads. You have a graphic manipulator here. I can just simply grab that and graphically place it. There's some arrows here. If I select a left arrow, it'll hold the outgoing slope and change the station. Grab the arrow on the other side, it'll hold the incoming slope and change the station. And I also have a number of text manipulators that I can use. I can click on these and key in different values for both station, elevation, and same with the slope. I can key in a different slope. You can also keep in mind undo button works with this. And you can also use some microstation tools. So for example, insert vertex tool, I can use that to create a new PI. And I can also use delete vertex. Now, once I've got that done, I can go to the next step of creating my point controls. But before I do that, I want to make an important point here. Remember that I used the slope stake line from the roadway corridor model as the horizontal control for my ditch corridor. Therefore, the stationing for the ditch corridor is taken from that slope stake line. Unless you start your ditch corridor at the very beginning of the slope stake line, the stationing for the ditch center line is not the same. Is not. Can we mute everyone? Okay. So unless you start your ditch corridor at the All right, now I'm not muted. Unless you start your ditch corridor at the very beginning of the slope stake line, the stationing for the ditch center line is not the same as the ditch corridor. There's two different station bases that you need to be aware of. You need to account for this when creating your data for the point controls, because the station data for the point controls must match the ditch corridor stationing, not the ditch centerline stationing. So what I've got here, my profile is based on the ditch centerline stationing. So how do I get this data reference to my slope stake stationing, which is my corridor stationing? I'm going to use a tool called Analyze Point. Go to Home. Under Model Analysis and Reporting, under Civil Analysis, it's right there. Analyze Point, it's an important tool. I recommend that you make it part of your quick access menu. So I'll select that tool. And it's prompting me, it says select element to analyze point. It's not very clear. What it's actually asking you for is to select the element that you're going to use as the reference for your your baseline station and offset data. So I'm going to select that. So now you can see it's tracking along the slope stake line, and it's giving me feedback wherever I move that mouse. I can now move this over to the profile view, and that allowed me to obtain corridor stationing for each of the profile PI points that I created. So for each of these PI points, I need to snap on those points, make sure I get the right one, and obtain the station. So the station for the first point is 415.94, reference to the slope stake line. This PI is 586.19. And this one is 734.34. So I'm going to record those, write those down. I already know what the elevations are. And the other pieces of data I need are the slopes. So I'm going to record this. This is 3.2765%, and this is 1.15%. Now I have all the information I need, and I can start the process of creating the point controls. To do that, as usual, I'm going to go to my corridor handles. I said before, I'll show you how useful these are. Just select it, move your mouse back over it, brings up the flyout menu. Go to Corridor Creation Tools, and here you have a full suite of tools that you can use to work with your corridor model. If you don't like using these flyout menus, you can go right up to the Corridors tab, and you have the same tools right up here in the ribbon menu. So I'll go to here to Corridor Creation Tools and select Create Point Control. So the first thing I need to do is establish the start and stop stations, the station range over which this point control will be applied. I'll change that. 0.94, which is the beginning of the corridor. 586.19. I need to give this control a description, so I'll call it ditch invert. The next step is to select the point in the template that you're going to control. So I'm going to go in the drop down, scroll down, and find this point called Profile Control. This is located right here. This is the bottom of the ditch force slope, and this is the point in the template that is to be controlled by the point control. What point controls do, they override the point constraints defined in the template. And this is the point that you must always choose, regardless of which lateral ditch template you select. All of the lateral ditch templates in the template library contain this point called Profile Control, and that's the point that you always want to select. The next option is the mode. You have horizontal, vertical, or both. We're going to select the vertical mode because what we're doing is we're going to change the vertical elevation of this point. We're not going to specify the horizontal location because we want that point to remain on this slope. So the point control will establish the vertical elevation, and then the corridor model will determine its horizontal location based on this slope. Number of different types of control options that you have for point controls. I won't have time to go into all these today. We're going to use the elevation and grade option. And what that means is that over the station range that you've identified, you're going to supply the starting elevation and the slope. So the first elevation is 875.27. And that first slope is minus 3.2765. Now that I've entered all my data, I just need a data point in the plan view window just to accept all these inputs. And then you'll see in the upper right corner, the profile for the first reach will be revised. All right, so that's the first reach. You need to go through that process again for the second reach. 86.19. End of the profile is 734.4. Going to keep that same description. And again, I'm going to select that same point. It's always the point that you'll choose. Leave all these options the same, just need to change the starting elevation and slope. And then accept that data. So now the corridor models now has an independent profile, independent of the slope stake line, and it conforms to the profile that I created earlier. Notice that I no longer have a low point. Contour grading is showing a continuous grade throughout. However, if I zoom in here, you see that I've got some glitches in my contours. So why is that happening? That's happening as a result of template drops that are crossing each other because of this deflection angle in the horizontal alignment. I activate my plan view here and go to level display. And I go to my 3D model, turn on these levels, these TC levels, and that will show the template drops. And you can see how the template drops are crossing here and causing just some glitches in the contour grading. So just as a general matter, this workflow that I'm showing you for lateral ditches, it really works best when the fill slope toe is fairly straight, does not have abrupt angular changes in the horizontal alignment. So if you run into this issue, there's a few approaches you can take to address the problem. The first one and the easiest one is to select the template drop graphic and go to properties and reduce the frequency of the template drops by increasing the interval. I'm going to increase this to 12. Corridor reprocesses, and you can see there's fewer template drops now. I turn off TC levels. Now I can look at the contour grading. You can see it's a bit improved, not perfect, but it's better than it was. Sometimes this works well, and sometimes it doesn't. So there's another approach you can take, and that's to add horizontal curves to your alignment. By adding horizontal curves, you can eliminate the crossings of the template drops. They will be radial to each other rather than crossing. To demonstrate this, let me just go to a different view here and take a look at a simple tail ditch that I created to demonstrate this. You can see I have the same problem here with some crossing templates. You see how they're crossing there. So I can go to geometry, to the table editor. This is a simple way to add horizontal curves to your alignment. Select the alignment. Now this is a tabular presentation of the geometry for your horizontal alignment. And it shows every time I select a row, it shows you which pair of tangents is being selected. So I'm going to change these radii. They're currently 0, no curves. I'm going to go ahead and change that to 30 for each one of these. If I close this dialog now, nothing will have been changed. Make sure that you press the apply button before you exit the dialog. Now you can see that the template drops are radial to each other, and I don't have any crossing. I can go back to my display. And turn off those TC levels, and you can see that the contour grading now is nice and smooth. But what about the lateral ditch? Let's go back to that. I have a problem with the lateral ditch. I can't use this method the way I used it with the tail ditch, because I'm using the slope stake line as my horizontal control, and I can't change the slope stake line. That's in the corridor model for the roadway. But what I can do, instead of using the roadway corridor slope stake line, as I did in this example, as the ditch corridor horizontal control, I can first place a separate alignment along the same path of the slope stake line, and then I can add horizontal curves to that alignment, which I do control. The idea here is to create an alignment that has gradual changes, but is still dependent on the slope stake line. I want to maintain that dependency so that when the roadway staff revise their design and the slope stake line moves, the ditch will move with it. Let's take a look at, to demonstrate that, I'll just go to the opposite side of the road here where I have a fairly abrupt change in the slope stake line. I'm going to go to level display of the roadway corridor and its 3D model and turn on one of these levels here that will show the template drops for the fill slope for the roadway. And what I'm going to do is create a horizontal alignment along the slope stake line here, and by snapping to it and creating a rule so that it's dependent on it. Now make sure that you have your persist, snaps, and rule toggle turned on so the rule is created. I'm going to lay out a horizontal alignment using complex by PI. And I'm going to be careful to make sure that I snap to the slope stake line features and not the template drops. So I'm not going to trust my AccuSnap at this point. I'm going to use the tentative button to make sure I'm snapping to the right feature. If you snap to the template drop feature here, a rule will not be created. So you need to make sure you're using the slope stake line feature. So I'm going to snap there to start. Actually, let me start back here. Actually, I want to first change my feature definition to top. I'll snap my way along. That's far enough. Now I'm going to go ahead and turn off that level so that I can see the geometry that I created. Go ahead and select that. And note that I have, this is what I'm looking for. I want to see these snap glyphs, these indicators that I have snapped to, and now there's a rule making that dependent on the slope stake line. And notice that the text manipulators are all gray, showing that I can't edit them because this alignment is now ruled to the slope stake line. All right, now that I've created that, I can go in and I can add a horizontal curve using the same table editor that I used before. I can select that. There's the spot that will be a problem, so I'm going to change that, put in a horizontal curve there. Don't forget to hit apply. Now I have a horizontal curve, and this can be edited even later after you've created your corridor model. You can always come back and change this value, this radius, to something else. You can also straighten out your alignments if you want. Even though this alignment is ruled, I can break the rule. I can grab one of these points, straighten it out. So you have that flexibility. And once this is the way you like it, you can then apply a template and create a lateral ditch in the same process that I used for this one. Now I'm not quite done with this. When I selected the slope stake line, remember I said that it has its own profile. This line that I just created does not have its own profile. I need to give it one. And the way to do that is to drape this over the existing terrain. And the tool for that is up here under Profile Creation, Profile from Surface. Make sure that my horizontal and vertical offsets are 0. I'm going to lock to start and lock to end because I want to apply this profile to the whole length of it. I'll follow the prompts. It says locate first element to profile. Select that and reset to complete. It says locate reference surface or reset for active terrain model. I'm going to use the active terrain model, so I'm going to reset. And then just confirm all the inputs in the tool settings dialog. And now if I select that, you can see that I now have an active profile. So now I'm ready to go ahead and create a lateral ditch there. All right, the next step in the process, now that we have our corridor model set up with its own profile, at this point, the default values for the template have been applied to all the ditch dimensions. I've done a hydraulic analysis. I need to make changes to this ditch to make it conform to meet the hydraulic requirements based on the analysis that was done. So this bench width, the bottom width of the ditch, the left and right slopes, the height of the channel lining, the thickness of the channel lining, all of this comes from the template. These are all the default values from the template, and I can change any of them. So the next step is to go ahead and make those changes. Now the DOT standard templates for ditches contain what are called parametric constraints. These allow for various ditch dimensions to be defined in reference to a parameter that you can change for the corridor model. And this allows you to edit the design without having to recreate the corridor model or create a whole bunch of new templates. So in this demo, I'm going to go ahead and widen the ditch near the bottom from about station 6+80 to the end. I'm going to widen that from 4 feet to 8 feet. And I also want a transition section. And I'll go ahead and do that. I'm going to need to create 2 parametric constraints, one for the widening and one for the transition. Now remember, just like with the point controls, since I'm making edits to the corridor model, the stationing that I use for the parametric constraints will use the ditch corridor model stationing, not the ditch centerline stationing. So for the parametric constraint, I'm going to, as usual, select my corridor handle, bring out the flyout menu, and the parametric constraints is the one with the question mark. Create parametric constraint. So I need to establish the station limits. I'm going to go from 680 to the end, which is 734.34. I'm going to select the parametric constraint that I want to change, and these are all the ones that are available. So I'll select the bottom width divided by 2. I'm going to change these values to from -2 to -4. And that will change the bottom width of the ditch from 4 feet to 8 feet. The value is negative because the ditch is constructed from right to left. I'm on the left side of the road. For ditches on the right side of the road, I would use positive values for bottom width divided by 2. So I've got everything input here. I just need to confirm those inputs. And now you can see the widening has occurred. The next step is to add my transition. And that's going to be 660 to 680. Now, the reason I picked those stations, it's explained in the new guidance document on the website, 5-to-1 transition ratio is being recommended for these transitions. So for a 4-foot expansion from 4 feet to 8 feet, that's going to occur entirely on one side of the ditch. I'm going to need a 20-foot long transition, 4-foot expansion times 5. So I'll start the transition at -2 and end it at -4. And then data point to confirm the inputs. So there's the transition. The next step in the process, the last step in the process, is to change my lining. In order to add or remove or change the ditch lining, it's necessary to revise the template that's being used for the corridor model for the station range where the change is needed. In the current example, I've used Class B riprap for the entire length of the ditch. I want to revise the lining so that the Class 2 riprap is being used for the 8-foot portion of the ditch down here. So again, I'm going to go to my corridor handle, open up my flyout menu, and go to Create Template Drop. So I'm going to create a new template drop. Check the boxes for start and end because I'm going to specify the limits of my new template drop. Those are the same station ranges as the 8-foot wide portion of the ditch. And then I need to select which template I want to use. I can go to that ellipsis button there, or I can use the heads up display again, Alt down arrow. So I'm going to change this from Class B to Class 2. Notice the other options you have: core fiber, concrete, earth, PSRM, and various types of riprap classes. So I'll confirm that selection and confirm station ranges and the drop interval. And you see that a new graphic has appeared now in plan view. If I select that, bring up my menu and go to properties, you see all the options I have for making edits to what I just created. I can come in here at any time and make these changes. If I change my mind about what kind of riprap I want there, it's very simple to come back in here and just choose a different one. You can also come in here and key in different station ranges if you want, or you can simply click on the text manipulator and key in a different station. And you have the option to graphically select where you want. You can snap to something if you need to. So you have a lot of options for changing, editing the template drops. So you can see how useful these graphics really are for working with your corridor model. Another option you have is edit the template drop. If you're familiar with template construction and design, you can come in here and make edits to the template drop itself. Just remember that when you do that, once a template has been dropped into a corridor, it's completely separate from the template library from which it came. Edits to the template drop do not change the templates in the library. So if you want your template changes to be reflected in your library, then go to the library first, make the changes there, then come back and use this tool, Synchronize with Library, and that will take the changes you've made in your library and then apply them to your corridor. So that's the demo. I think we have time for some questions now. I'll just say that if you do have questions in the future, feel free to reach out to Bill Elam, who's leading the effort to assist DOT Hydro in its migration to ORD. And feel free, you can also reach out to me if you like, if you have any questions about DOT dish design workflows using ORD. And I think we've got a little bit of time for any questions.
Appreciate that, Carl. That's very in-depth. I think there's been a couple questions, and I'm just going to read them. You may or may not have answered them, but can the PI data be exported in any way, maybe like a report or CSV spreadsheet, Excel spreadsheet?
I go to my profile window and select that profile. I can get a profile report. And I believe you have some options for exporting right there.
Great.
So I don't see a CSV option, but I do see an Excel option.
Yeah.
And you have a lot of different reporting options, as you can see.
All right.
Okay.
Can we change these control points to even stations? I think it might be referring to the profile.
Yeah, you can. If you select this, you have all the, you can key in a specific value. So you can, I can make that 170.
Okay. Someone commented, can't you just make the profile an active profile instead of point controls? I guess you need the ditch profile to use
Good
the roadway
question. Yeah,
stationing.
it's very typical. If I was doing a tail ditch, if I was, remember in this for the lateral ditch, we didn't really have a step where we created a horizontal and vertical because we just took that directly from the slope stake line. But for a tail ditch, that's exactly what you do. You have to lay out a horizontal, then you create a vertical, and then you set it active. For this, this profile here, remember that this ditch line is being created by the corridor model itself. So it has its own profile. You can, if I hover over it, you can see active profile. It's profile by template. So it's, that profile is being created by the corridor model. So the only reason I'm using this here is to create the profile that I want, and then I use the point controls to do that. It's a bit of a chicken and egg thing when you have this situation, because you know a profile, you make it a profile that you're making active, you're applying that to a horizontal alignment. We don't really have a horizontal alignment for the ditch center. The ditch center is being produced by the corridor model itself. It's a feature of the corridor model. And so we don't really know where this is going to end up. We have an elevation and we have a slope. And so, you know, I could create a horizontal alignment, but then, you know, what is it that's going to change, right? If I'm going to create this horizontally and vertically, then what's going to change is my slope. So if you want to do that, you can. You have that option. If you want to have a variable side slope, you can do that. So there's a lot of different ways that you can work on this. I hope that answered the question.
Yeah. Since ditch stationing will now be independent and different from roadway centerline, as it has traditionally been done, what station will be shown on the ditch detail to its location on the roadway corridor?
Yeah, excellent question, and that's covered in the. I didn't have time today to cover construction layout and how you use ORD to do that, but the quick answer is it's this tool, analyze point. We definitely do want to be able to have this information in reference to the baseline data for sure. So instead of selecting this, I'll select the roadway baseline, and now I'm tracking on the roadway baseline, and now I can, in my profile or in plan view or even in cross section view, you know, I can snap on these points and it will give me the station based on the roadway baseline. So now I have a roadway baseline station of 16 plus 45 and an offset. So yeah, you can use this tool to give you the location of your control points, your ditch control points, relative to your roadway baseline. Good question.
Okay. If anybody has any additional questions, you can type them in the chat or feel free to raise your hand and I can call on you if anybody has some additional questions. I think the rest are just comments on an awesome job that you did presenting that. There's a lot of information. I mean, it's exciting to see
Yeah, I know it was
the
dense and I
headway.
went through it quick. I'll just say real quick here. Let me go to the corridors now that I just have a few minutes for ditch quantities. I didn't really mention that, but this is mentioned in the ditch manual. You have component quantities. You just click on this, select your corridor, and you can get quantities that way. It's very, very quick and easy. You have another option. I can remember where it is. All this is in the let's see, home, I think, corridor reports. We have another one called, under civil analysis, element component quantities. And you get another way to report quantities, and each of them have pluses and minuses, and this is discussed in the ditch manual, ditch design manual.
I think we
Let's
got a
see.
few more questions coming in.
Yep, I see that. Can you make the ditch alignment stations match the road alignment stations instead of the cut fill line? I'm not quite sure what's being asked there.
Yeah, I'm not sure either.
It's part not doable. They're two different lengths. If you had like a vertical curve, I mean, horizontal curve on the inside and outside, those are different lengths. So even if you restation the start station of 10 to match roadway alignments, your inside and outside slope stake will be different station when you enter a curve.
That's right. Yeah, there's three different, that's a good point. I mean, there's three different sets of stationing. We have the baseline stationing for the roadway. We have the slope stake line, which is different. And we have the ditch center line. And they all serve different purposes. The goal here really is to, the ideal goal is to have your ditch tied to your slope stake line so that when the slope stake line moves, and we all know it does, right? We've worked on these projects. We know how this happens. We get our ditches designed, and then there's a design change. The guardrail is introduced or something that pushes the toe slope out, or there's change in the side slope, and it's just a disaster, right? If you're a hydro engineer, you got to redo all your modeling all over. And the way this is set up, this slope stake line moves, the ditch goes with it automatically. Now, I'm not saying that's you're done. Of course, you have to go back in here and look at how that affected your ditch. You need to look at your profile and everything else and your cross sections and maybe make some tweaks in response to that. But that's a heck of a lot better than starting over again.
And if that's the case, is the profile what controls it? Is that what lock?
What is going to control this is the point controls, and the point controls are applied, really along here, along the station base, and then applied to the center line. So this profile that I created isn't controlling anything. That's just something, I laid in the profile to determine what I want the profile to be so that I could get the data and then use that data to create the point controls. But it's the point controls in the corridor model that are driving the location of the ditch, both vertically and horizontally.
Someone asked to get the ditch profile into a profile plan sheet. Are you redrawing them manually?
No, not at all. Yeah, so the procedure I would recommend would be to create a new DGN and reference up your corridor model, and then use the geometry tool called your offset, one of your offset tools here, single offset entire, and then just create a horizontal alignment on top of this ditch line here from the corridor. And at that point, you could use a feature style that will give you a flow arrows, because when you do that, you can reverse the direction. You can lay out that line in the direction that you want, so that it's following the flow of the ditch. And then when you have that horizontal, you can then apply the vertical to it. And then that file can then be used by roadway to simply just reference up that DGN with your horizontal and verticals in it. And then you can very quickly apply, project that ditch profile to your roadway profiles. As I said, that's shown in that video on my YouTube channel, how to do that. It's very quick. So yeah, you don't have to do that. That would be something I think the hydro would do. They would take, like I said, create a new DGN file and put all the ditch controls in that DGN, and that would be a DGN that roadway can then reference to project those profiles onto the roadway profiles.
Okay. Carl, there's a couple more questions if you can stick around and
Oh,
answer
absolutely.
them. But
Yep.
since it's 1 o'clock, I was just going to do a little wrap-up speech, but then we're going to continue on with a few more questions.
Mm-hmm.
But I just want to thank you for coming and giving the presentation today. We really do appreciate it. It's very informative, and we hope to have you back. Hopefully this summer we can do some hands-on training, and hopefully maybe you can come back and do something of that sort. I think a lot of people want to actually practice this themselves and get their hands on it. I just wanted to remind everybody that NCLUG is hosting a Toys for Tots drive, and just encourage everybody to go and either give monetarily, or you can buy a virtual toy on the virtual toy box, or even just support it locally. If your local CVS or wherever there might be a Toys for Tots drop off, just participate there. And you don't have to let us know. We just really just trying to encourage you to go out there and participate and support that charity in our honor. So we'd appreciate that. And then this is our last webinar, of course, for the year, but next week we are holding a NCLUG holiday cheer event, which will just be like a trivia night. So it's something just for fun. And I think that's 5 to 6 next Wednesday night. So we hope that y'all will register for that on our website and check it out. I'm not 100% sure at this moment what we have in store for 2022, but we will be doing something. So of course, stay tuned to your inbox. Encourage others to join and become NCLUG members. If you're interested in being on the board, just reach out to us at events@nclug.com. We'd like to hear your input. So with that, I'm gonna again thank Carl for giving us this presentation, and hopefully if anybody wants to stick around and ask a few more questions, he'll stick around and help us answer those. And of course, we'll keep recording, and that will be posted on our website. And hopefully we'll have PDH stuff out to everybody by next week. So thanks everybody for joining us. So Carl, there was a couple more questions on there. I don't know if you saw those. I think one was about the fill slopes changing from 3 to 4, 3 to 1s to 4 to 1s, and using the ditch template that matches the fill slopes. Will it follow the same slope?
Right. Great question. So what you would do is, for example, this is not a good example because they're different. But if, for example, I had a ditch here that was continuous, if my ditch fore slope is continuous with the roadway fill slope, and then the roadway fill slope changes, what I would need to do would be to come into my corridor model and add a parametric constraint and select, the right side slope, and then change that slope so that it matched the new slope of the roadway fill slope. That's how I would do that.
Okay. There's a lot of thanking you, Carl.
The special cut ditch. If the special cut ditch is remaining with the roadway engineer to model, does the ditch lining need to be reflected in the roadway template? I think the answer to that is yes. The video that I have on my YouTube channel shows how to create the ditch controls, how the hydro staff would create the ditch controls, and then how the roadway people would use those controls to modify their corridor. So yeah, it's still part of the roadway corridor model. So if any ditch lining if you're wanting to show ditch lining in the cross sections, yeah, that would need to be part of the template that's being used for the roadway corridor model. I think that's the question that's being asked.
And Carl, the video that you're referencing, if you send me that link, I can put it with the video or put a little hyperlink in with where
Okay.
this video is stored so that people
Okay.
can have easy access to find it.
Sure. How do you export the ditch contours to actual polylines or DGN file? I have a workflow set up for how to do that for pond grading. I've never thought to apply that to ditch contours, but it is possible. I don't know how I could. It's a bit of an involved process, so I don't think I could explain it right now. But
But it is possible.
It is possible, yeah.
Yeah, there might be some other Bentley tutorial videos and stuff on how to do that.
There's ways to turn those graphics into polylines.
Okay.
I think it's actually the analyze point tool that you use, if I remember. All right, and I think that was the last of the questions.
Yeah. Any final questions? Now's our opportunity to ask.
For those that are still on, I've been talking to Patty about coming back and doing another one on modeling ditch intersections. So I do have a workflow set up for that. That's going to involve a lot more advanced geometry, as well as some developing design terrain models, surface templates, and linear templates. The delay on that is I'm trying to get this into a civil cell. And in the process of working on this with Bentley, we've discovered several software defects that's keeping us from doing that. So I'm going to keep working on that problem, but I may end up just setting aside the civil cell issue for now, and so I can show you all how to do the modeling.
Yeah, wonderful. Okay. Well, there is no other additional questions. Carl, it was a great presentation. Really appreciate you doing that. Look forward to having you back.
All right. Thank you very much. I enjoyed it. All right. Good day, everyone.
Thanks, everybody.
And happy holidays and Merry Christmas.
You too. Merry Christmas.